All right, here's a couple of questions from the worksheet. They say they have a mixture of 2 moles, 3 moles, and 4 moles, and 5 moles of gases, and they exert a total pressure of 800 torr. And they want to know what the partial pressure of each gas. So they give us a pressure, 800 torr, but they don't give us a volume. They don't give us a temperature. They do give us an amount of moles, though. So I'm just looking for a formula. I don't really see a formula that just relates pressure and moles. I do see this thing at the bottom, though, where, like it say, they have a total pressure. So maybe it's this one here we can use. So the pressure total in a system will be equal to the pressure due to hydrogen plus the pressure due to ammonia plus the pressure of carbon dioxide and the pressure of nitrogen. So all together. But I don't have a pressure. I have moles of each of these. But I do know that a mole of hydrogen exerts the same pressure as a mole of nitrogen. Yeah, there's 3 moles to 2 moles, but each mole themselves, doesn't matter what gas there is, each mole will contribute the same amount. Okay, doesn't matter what gas. So maybe what I could do is I could just add up how many moles of gas I have. And then I could use a ratio to figure out for each one of them what percentage or what amount of the 800 they contribute. So if I add them up, 2 plus 3 is 5, plus 4 is 9, plus 5 is 14. So there's 14 moles of, 14.0 moles of gas total. So if I want to know what the pressure due to hydrogen is, I can say the pressure is however many moles of hydrogen I have, 2, and that's 2 moles of a total of 14 moles. And then if I times that by the total pressure, 2 over 14 times 800, let me get my sheet here, that'll give me the amount of the 800 that's due to hydrogen. So let me do that. I think that's about 114. And then do the same thing for each of the other gases. Pressure due to ammonia will be 3 moles over 14 moles times 800. That one comes out to 171 torr. And just do that for each one of them. And then it might be interesting, once you get all the other numbers up, add them together and make sure you come up with 800. It's not really a formula, I guess, that we used from over here. It's more logic, just figuring out. And it is the Dalton's law of partial pressures, because each mole of any gas exhibits the same kind of pressure. That's why you can do this kind of ratio thing. All right, number 10 here. It says a mixture of gases, and I have this many mole or grams. I'm going to have to convert that. Grams of hydrogen, grams of ammonia. What's the partial pressure of each gas? If the volume of the container is 10 liters, so volume is 10.0 liters, and the temperature is held at 40, so 40 plus 273, I think it's 313.15 Kelvin. And they want to know what the partial pressure of each gas is. And moles I don't know, but because I have grams, I can determine moles. So that'll be the first thing I'll want to do, is I want to figure out the moles of the first gas is nitrogen. So it's mass over molar mass. The mass is 2.14 grams divided by the molar mass of nitrogen. Now that nitrogen is 2, so nitrogen is 1401 times 2 would be 2802 grams per mole. And figure out what that number comes out to be. I don't know if I wrote that down. Anyway, figure out that number, and then take that number, and if I want to figure out the pressure, the partial pressure due to nitrogen, then since I'm not doing a second pressure or temperature, I'm not changing any of those values. I'm just wanting to know a condition of one of the gases. So I'm not going to use any of these formulas. Yeah, so this is the one I'm going to use, because that one will tell me if I have three of the conditions, I can figure out the fourth one. So the pressure will be nRT over V. I just manipulated that formula there. So the number of moles comes from right there. Put that in, times your R value, 8.3145 kilopascal liters per Kelvin mole, times the temperature, 313.15 Kelvin. And I have my moles here. So multiply, and I have to divide by the volume. Volume is 10 liters total. Yep, 10.0 liters total. So the liters cancel, the kelvins cancel, and these are in moles, so the moles cancel. So the thing I'm left with is kilopascals. And this one comes out to 19.9 rounded. We'll call it 19.885. And if you round it, it's 19.9 kilopascals. So that's the partial pressure in the container due to nitrogen. Then I just have to do the hydrogen one and the ammonia one. Okay, I hope that helps you out getting going with those two questions.